Hey guys, welcome back to the shop. Continuing on with my Back to Basics series, today I want to talk about one of the most versatile and important machines in any shop, and that's the engine lathe. So at first glance, the lathe can be pretty intimidating. There's a lot of handles and switches and knobs and stuff, but if we break it down to its key components, you'll see that it's really not. Let me get this thing cleaned up, and then we'll take a quick walk around it and get a little more familiar with it. Guys, quick alibi on running that machine. That thing can absolutely eat your lunch. I will recommend no loose clothing, definitely no gloves. I try and take my ring off whenever I run it, and keep my sleeves pushed up. Again, it's a rotating tool that makes a lot of torque. It can suck you in there and give you a very, very bad day. So be careful and go further, do some more research on the safest ways to run these tools. Thanks, guys. Starting off with the front of the lathe, we have the headstock. Attached to the headstock is the chuck. This particular chuck's a 3-jaw chuck because, well, it's got 3 jaws. On the bottom of that, we have kind of what you can consider a transmission, but really it's a gearbox. And its job is to change the ratio of the lead screw. And here's the lead screw. Moving forward, we've got what we call a carriage, because it carries all the work and does most of the work. Front of the carriage is the apron, and on top of the carriage is the cross slide. Sitting on top of the cross slide is the compound rest, and finally, the tool post. And on the back of the lathe, we've got the tailstock. Makes sense, right? One end's the headstock, the other end's the tailstock. So the lathe can do a lot of things. You can set this machine up to do a whole host of different things. But some of the primary things that we're going to touch on today is just kind of the key elements of why a lathe is useful. Facing is one operation, and that's where you cut the face of your part. So we refer to this end as the face. And then turning, if we want to reduce the outside diameter of this part, we will turn it and then run a tool across the outside diameter, and that will be called turning, or boring, which is what this tool in here is set up for if you want to change the inside diameter of the part. So basically, I mean, we can do a lot of things, but what we're going to talk about today is 3 key functions: facing, boring, and turning. So making something shorter, making something smaller on the outside, or making something bigger on the inside with boring. First thing we'll have a look at is boring, just since I got the tool set up. Now this particular tool right here, you can see it's long and thin, and its job is to reach inside that bore and make it larger. Let's take a look at what that looks like. So I'm using the controls on the carriage to move everything forward, and then the cross slide to move it in and out. You see the cross slide runs the tool in, runs the tool out, and the carriage, we can move the whole deal forward and aft. So I'm just bringing the tool up to the inside diameter here, and we'll just touch off. And we can cut this 2 ways. We can set our inside diameter by running the cross slide out and plunging into the material like that. Or what we can do is we can set inside and then pull the cross slide out and open up that inside diameter that way as well. So what we're doing there is boring. That's a boring operation. I've changed the tool here just to a regular turning tool. And this is a hand ground tool that I ground by hand. It has a small chip relief in it. You'll see that, that shape right there. Let's see if you can see that or not. That groove in there, its purpose is to allow that chip to hit in there, bend, and then break off, so you don't get a big mess. So what we're going to do is we're going to run this along the outside diameter, and we're going to effectively decrease the outside diameter of this part. Okay, now you can see we've ran the tool along the outside diameter of the part and we've reduced that overall diameter. That's turning. Now what we're going to do is we're going to use the same tooling setup and we're going to do a facing cut. So remember, we spoke about this being the face of the part. So what I'm going to do is I'm going to come in from the side here, the outside diameter, and I'm going to run the tool across the face of it, effectively shortening the overall length of the part. That's a nice cut on there. So now we've shortened the length of the part with a facing cut, we've reduced the outside of the diameter with a turning cut, and we've increased the inside diameter with a boring operation. But this is all it is. You're moving the part, right? Part's turning, and you're moving a tool along the outside diameter, along the face, or along the inside diameter to increase that size or decrease that size, you know, if it's on the outside diameter or the overall length. All right, guys, this is the dial on the hand wheel for the cross slide. You can see it's graduated in thousandths of an inch. Maybe you can't see that. I'm telling you, it's graduated in thousandths of an inch. Now, what this does is as we turn this, this will tell us, hey, you're moving the whole cross slide 1/1000th of an inch. So what we'll do typically is we'll touch off on the work and then we'll set our 0. This brass knob allows us to turn this sleeve with the indicated numbers on it. We'll lock it in place. Now say, hey, we need to remove X amount off of the outside diameter. We'll dial in that correct number. We're going to remove that much, and then we'll run our operation. Now, something to keep in mind, lathes are marked in different ways. This one is direct 1-to-1. Now, what I mean by that is if I dial in 60 thousandths, it's going to move this cross slide 60 thousandths. What you need to understand is when you are cutting a part, let me pull this part out and see if I can explain this. When you're cutting this part, for instance, if you move that dial in 60 thousandths, so that means your tool is plunging 60 thousandths from the face of this work. You've got to think about this in 3 dimensions, or at least 2. The fact that there's 2 sides of this cut, because as it comes around, it's going to also cut the other side 60 thousandths. So effectively, that number is going to be half of your overall removal of material. So if I move the tool in 60 thousandths, it's going to cut 60 thousandths from this side and 60 thousandths from that side. Now, if I wanted to cut 60, you got it, I would turn in 30 because that would move my tool 30 thousandths into the work and an effective cut of 60 thousandths. Are we in frame? An effective cut of 60 thousandths. I hope that makes sense. All right, guys, we've moved up to the compound rest. And the reason it's called the compound rest is right here. Look at all those numbers. We can change the angle of the dangle. We can change the angle at which the compound rest sits. We can loosen these nuts here. There's one on the other side. Let me reach over here. And then what we can do is we can adjust to where we need it. Typically, when we're doing those 3 operations that we spoke about, the facing, the boring, and the turning, this is inconsequential. And the reason it's inconsequential is because we can move the tool post around to make it match up to the face of the work or wherever we need it on the face of the work. So for this one, I'll just leave it set here at 30 degrees. Now, when you get into threading or single point threading with the lathe, that's when the compound rest becomes more important. But we're not gonna worry too much about it. This is a back to basics video, and we're just showing just the basic operations of the lathe here. Let's move to the back of the compound rest, and we'll take a look at another hand wheel. All right, look at this. This looks just like the other wheel, and that's basically because it is. We have the cross slide down here and the compound up here. Now let me move this handle off here so we can get a better look. But what this is basically the same thing, right? We have a locking sleeve with graduated increments on it, and it is the same way. So if we move it 5 thousandth, the compound rest is going to move 5 thousandth. So what you need to keep in mind, though, is this direct reflection is not going to turn up on the work. So if you move this in 5 thousandths, it does not mean you're going to have an effective material removal of 5/1000ths on the part because of the angle here. What I'm saying is we've got some geometry to do. That's later down the road. It becomes super important, like when we're cutting threads or you know, cutting tapers or anything like that. But for this, we'll just leave it locked down at 0. Throw the old hickory speed wheel back on it and move on to the next one. Okay, now this is the tool post. And up here we've got a nut. Basically the way this is set up is it has a T slot, just like a milling machine. So the bottom has got the T-bar in it, and it lives right in the compound rest here. Let me see if I took it out. There we go. And we can set this angle at whatever we want. Now, this angle is going to be determined by how we want to cut our part and what part of the cutting tool we want to interface with the work. You'll have to play with it and figure out, based on what you're cutting, what the best angle for that is. So anyways, the way this works is you have a lever here that locks down this wedge. This wedge right here moves up and down with this handle, and it basically sandwiches inside this dovetail cut and locks the tool in place. All right, guys, so one of the more intricate parts of the lathe is the gearbox. Now, not all lathes have gearboxes. I'm lucky this one does. So the purpose of the gearbox is to use the rotating energy from the electric motor that powers it to run this lead screw right here. And that lead screw can be connected and disconnected to the cross slide or to the carriage through a clutch or a series of half nuts. And you know, the clutch operation is used for, you can run the carriage. Now the clutching operation is used to run the carriage, like if you want to do a very long, say, turning cut, and you've got to, you know, reduce the outside diameter of something, and it's a very long cut, and you need a nice finish. You can get a more uniform finish by using that and allowing the lathe to do all the work. Now the half nuts are more precise, and we use those specifically for single point threading. So coming back down to here, you'll see a series of numbers and 2 levers. So what we do, say that specifically we need a 1/4-20 cut. So we've got a part in the lathe that's 1/4 inch, and we need 20 threads per inch. So what we want to do is we want to find our number here that equates to our TPI. So as it says right here, threads per inch, and we want 20. So we'll come over to 20, and 20 has us right here in this slot. So what we'll do is we'll move the gearbox up here. Get it just right. Sometimes it doesn't want to go in. There it is. And we'll come over to this here is asking for B. So this one lines up directly, and this one has a letter that equates to what position they want the first one in. So you'll move this over to B and set it in place. Now, when we turn this on, that lead screw is going to turn at a rate that will produce 20 threads per inch. There it goes. Of course, I'm a genius and I ran it backwards, but let's take another look. Now it's done all the math, and at the rate at which that spindle is turning, the cross slide is moving at a rate which will produce 20 grooves or 20 threads per inch of feed on the material. Now guys, there's absolutely so much more that this lathe can do. There's attachments. I have attachments that we could effectively turn this into a milling machine. There's ways to run 5 feet of bar stock through it. We can put rifling into, say, a barrel for a gun or something like that. There's a million things that these can do. When I started running this lathe, actually this is my second lathe. I got this after my grandpa passed. I might have mentioned that. But I had a smaller, cheaper offshore lathe that worked fine. And I started basically with a need for spacers and washers and things of that nature that I needed for cars I was building. I think at the time I had a 69 Fastback that was, yeah, I think that was the car I had when I first got into running a lathe. And I looked for any reason to use that machine. Standoffs for the radiator, custom mounts, you know, things of that nature. And it really opened up my eyes to the things that I was capable of doing. Now, it is a pretty hefty investment to buy a machine like this and to tool it up and to do all that stuff. But I just want to express to you guys that this is not magic, and it's not something that is reserved for the machine shop. You can do this stuff with really, really quality results. A little bit of investment here. I think nowadays you could probably get a machine like this for a couple $1,000. And if you tool up, you know, in the long run, you'll be really saving yourself a lot of money, because you can make these parts and do these things that you couldn't ordinarily otherwise do. Anyways, guys, thank you so much for coming around. This Back to Basics series is going to be a series of videos that continue to show just the basic stuff that we can do in the shop with the tools that we have, and the things that are foundational to making parts and building these cars or whatever you're doing. This translates to a lot of different areas. So anyways, guys, like, comment, subscribe as always. Thank you so much. We'll see ya back soon.